Hello everyone. So right now we're going to look at some factoring that includes trinomials, but they're special types of trinomials. So we're still going to be looking at trinomials that fall into the categories x squared plus bx plus c or ax squared plus bx plus c. The rules that you learned before, either product sum or slide and divide, those will still work, all right? The only difference is I'm just going to show you a shortcut. So the original methods you guys learned will still certainly work, but we're going to look at a shortcut today for perfect square trinomials, or a PST. So I'm going to wedge that right in between those because that falls within both of those categories, okay? So let's start on the back side of your notes. We've talked through this before. I'm going to pick up with a binomial by a binomial, just so we recall that process. So that's your FOIL process. So 3x times 4x is 12x squared. 3x times 2 is 6x. Negative 1 times 4x is negative 4x. And negative 1 times 2 is negative 2. So remember, we can always combine those, or we usually can combine those two middle terms, leaving me with 12x squared plus 2x minus 2. All right. If we were asked to factor this is something we could do with product sum, with our slide and divide and then product sum. We also could look for a greatest common factor first. All right, but here we were being asked to multiply, so we FOILed that out. The same rules apply when it's a binomial by a trinomial. You just have to make sure everything in that first factor gets multiplied by everything in the second factor. So x has to get multiplied by x squared, leaving me with x cubed. X then has to get multiplied by negative 4x, leaving me with negative 4x squared. Then x has to get multiplied with negative 5, leaving me with negative 5x. As I keep going, now 2 has to get multiplied with the x squared. So we'll have a plus 2x squared. I'm lining it up underneath the like term, so it's easy for me to add in a minute. Then 2 has to get multiplied with negative 4x, making it negative 8x. And 2 has to get multiplied with negative 5, making it negative 10. So if I combine my like terms here, then I can see we have x cubed. Oops, that doesn't look like a cubed. And then negative 4x squared plus 2x squared is a negative 2x squared. Remember, when you're adding, your powers don't change. Then we want to add the negative 5x and the 8x to give me negative 13x, excuse me. And then bring down the negative 10. All right. So that leads me into this special product here, which is x plus 3 squared. So this is what we're going to focus on today. So when you see x plus 3 squared, what that really means is that we want to write x plus 3 times itself, or we're going to write it twice. So x plus 3 times x plus 3, that's what this really says. If you do x squared plus 3 squared, or x squared plus 9, you're missing something in the middle, okay? You're missing a middle term. And so this would give you the wrong answer. Don't do that. That's the most common mistake I see with this, is that people say x squared plus 9. Even my kids in calculus say do that, and it gets you the wrong answer every time. So make sure you write it twice, and then we're thinking about foiling it out. We'll get rid of the red here. So x times x would be x squared. X times 3 would be 3x. 3 times x would be 3x. And then 3 times 3 would be plus 9. So if you notice here, oops, these two terms in the middle, those are exactly the same thing. And that's going to happen every single time. Well, 3x plus 3x gives you plus 6x when I combine that. And this last term out here, that's really just 3 times 3, right? So when we are done, x squared plus 6x plus 9 is our expanded version of x plus 3 squared. And that 6x is what would have been missing over here. All right. So let's talk about what that looks like when we start to factor. Okay. So here is the same thing we just looked at, x plus 3 squared. gives us x plus 3 times x plus 3, which is x squared plus 6x plus 9. Excuse me. So if you notice, the middle term here is 2 times 3 times x. So we just multiplied those three things together, the exponent times the last number times the first term. That's what gives me the 6x, 2 times 3 times x. The first term is just x squared, is just from taking x and squaring it. And the last term is from taking 3 and squaring it, this last piece here. So to get the first term, we do x squared. To get the last term, we do 3 squared. And the middle is 2 times x times 3. All right. So think about it if I just have a general one, a plus b squared. To get the first term here, we're going to do the first part squared. So a squared. All right. To get the last term, we're going to do the last thing squared. So that would be b squared. To get the middle piece, we have to do, and it's a plus here, so I'm going to use a plus when I write it down, 2 times the first thing times the second thing. So 2 times a times b. And then the last term is always positive, so I'm going to leave it as a plus b squared. So anytime you square a number, it's positive. So this is our simplified version. When we have a plus b squared, you can rewrite that as a squared plus 2ab plus b squared. So that's the shorthand for multiplying it out. We can also reverse that though. If you recognize that you have a first term as a perfect square, a last term as a perfect square, and the middle is 2 times the square root of those two numbers, then you can rewrite or factor as a plus b squared. Oops. So let's take a look here. We have x squared plus 10x plus 25. So let's see if we can use our generalization here. Well, x squared is just x that has been squared. All right. 25 is 5 that has been squared. And 10 is 2 times the first thing squared, which was x, times the last thing squared, which was 5. So this is a perfect square trinomial because it fits in that formula, which means its factors are x plus 5 squared. The first thing that we squared and the last thing is what goes into your factors, okay? The other thing, if you don't recognize that, it's not a big deal. You can say, okay, x squared plus 10x plus 25, go with our product sum. What two numbers multiply to 25 that add to 10? Well, it would be 5 and 5. So my factors are x plus 5, x plus 5, and that's really x plus 5 squared, all right? So we're not necessarily, it's not going to hurt you to still do the product sum, just like this, but this is a faster way if you recognize it, all right? And what I'm looking for when I start these is the first term and the last term to be perfect squares. So x squared and 25 were perfect squares. Here, x squared and 36 are perfect squares, so I just have to check the middle. Well, to get x squared, I squared x. To get 36, I squared 6. And then to get the middle term, it would have to be 2 times x times 6. Well, hey, 2 times 6 is 12, and I definitely get that there. This time it's a minus. So what that means in my factors is that I'm going to have a minus instead of a plus. So I know that the thing I squared first to get x squared was x. The thing I squared last to get 36 was 6. And I need the minus there. So my factors would be x minus 6 squared. All right. So let's do one more together. This one's a little bit trickier. So we have to think, okay, what did I square to get 4x squared? Well, the square root of 4 is 2, and x has also been squared. What did I square to get 49? Well, that was 7. So we want to see is the middle 2 times 2x, the first thing, times 7. Well, 2 times 2 is 4x. 4x times 7 is 28x. So yeah, that checks. So my factors won't be x plus something. Now it has to be 2x and a 7. And if the middle term is positive, then the positive goes down here. Oops. And so it's 2x plus 7 squared would be my two factors. Or you could write them as 2x plus 7 and 2x plus 7. All right, so go ahead and try assignment 5 now.